Hey everybody, Swarsky here. We're just going to go over page 27 and 28. So if you need to, pause the video, get to those pieces, and let's get to what we need to. Now I'm going to go pretty quick, so if you want to pause, rewind, double check, that is going to be kind of on you. I don't want to try and explain too much here on this video and make it into a 15-minute one. Trying to keep it around 5 minutes, so we'll see how we do. So the first one here, we have an airplane climbs at an angle of 13 degrees. What's the distance it has traveled? Now, here's the thing, is that I'm going to show you two ways because I think that this can be interpreted both ways. So, for sure, it's rising at 13 degrees. And we want to know when it's at 30,000 feet. Here's where the questions come in. Are we talking about this one or this one? And I guess you could make arguments for both. So I'm going to just solve for both. So if I solve for x, we'll do x first. That means that we're going sine 13, right? 30,000 over x. And if I solve for y, I'm doing tangent instead of sine. So tangent 13 equals, same thing, 30,000 over y. Okay, both of these I'm going to divide. So if I do the tangent, that's going to give me 129,000. We'll just go to the nearest whole thing, 944 feet. And if I'm doing this one, that'll give me 13,336. Oops, I messed that up because it's 133. How many? 133,362 about feet that way. Okay. So makes sense if this is really small. I mean, 13 degrees gets you to 30,000. You got to imagine that this is going to be way bigger because you have 77 degrees, which is going to be a lot. So that's why this being a lot makes sense. And then obviously this would be the biggest one out of the bunch. Okay. There's the first one. So either one of it depends. I think that's open to interpretation. Either one would be acceptable, but you should get either one of those. Next one we're dealing with is the ski resort. So here's our mountain. Here's our ski lift. We're saying a couple things. We know that the height on this one is 1,200 feet. We know that it's rising at an angle of 20 degrees and 0.75. And we want to know how far the chairlift traveled up the side of the mountain. That one, I'm going to say that was what we were looking for. So in this case, that's going to be sine 20.75, opposite hypotenuse. Again, you're dividing, which would give you, I'm going to round to the nearest whole, so 3387. It was like 0.0 something, but we'll just call it there. Okay. This one, I think, just the way that it was being worded, leaves it that that's the one that we're looking for. Next one, we got terribly drawn lamppost. Here's our bird wings. Oops. Wings. Beak. There he is. We got an observer this way. Want to know how high it is? From person to bird is 25. It's saying that the angle of depression, which would be this one right here, or this right here. So either one, you get the same, but I'm going to keep it as this piece right there, which is, again, this is kind of seeing a pattern, kind of always being sine. Sine x over 25, and we'll multiply because x is on top, so it'll be 25 times that, so we'll get 14.3 meters. Go to the nearest tenth on that one. Okay. All right. Oops, I went too far on that one. Oh, we got a big light post. Here's our observer there. We got ship, terribly drawn. Sending distress, we want to know how far it is from the shore. It's 55 foot tall. Our angle of depression is 9.5, or the angle of elevation on the other side here is 9.5. So then I would go, in this case would be tangent 9.5, opposite's 55, adjacent's X. Divide those. I get 328.7, we'll call it feet. There. Okay. Again, this should be a pretty big number. This is only 9.5 degrees, and that gets us 55 feet. So you're going to realize that it's going to be pretty big for what's remaining. Okay. We're actually getting the angle one on this one. So this one's taking a couple of steps. It's saying that residential wheelchair can't exceed 9.5 degrees. Commercial can't exceed 5. So what I'm going to do is I have these dimensions, and I'm seeing, does it fit commercial or residential? So I have to find that angle measure. Okay. So that means I'm looking for this, and I'm saying that the vertical rise is 1.5, the ramp is 8.5. Now, if you did, or if you said, you put, let me change it, you put this is 8.5, I'll show you what it is. Neither one works, but if I'm just talking about the size, I'm thinking it's this one, the length of the ramp. So let's do that. Either for the first one, that would be, for theta, would be sine. So sine theta, 1.5 over 8.5. Inverse sine, so I'm going to go sine inverse of the ratio. And I'll get, for the sine one, I'll get 10.2 degrees. So that fails on both ends. If I do the other one where it's here, that would be tangent of theta. Same ratio, 1.5 over 8.5. So I'll go tan inverse 1.5, 8.5, and I'll get actually 10 degrees on that. So both will fail. Neither the commercial or residential will work for that dimension. It'd have to be longer, or it'd have to be not as high. So that's the options you got. Okay? All right. Next one, we got kite flying. Woo. Terrible kite. It's flying here. We want to know how high the kite is. It's at an angle of elevation from the ground at 40 degrees, 200-foot string from there. So sine 40, x over 200. Multiplying on this one, 200 times sine 40, that would be 128.6, and that would be feet. Okay. Again, this whole thing is being able to set it up. Oops. Now, I have, there's actually in our other classwork here after this, there's this exact same problem, so you obviously don't have to do it again, but the picture's in here that makes it a little easier. Okay, so it's saying that we're here, we are looking for the angle of depression, knowing that it's 995 to the middle. It's this support is 297. I'm looking for that, so that would also be, so I can either move this, think about this 995 right here. So now I have opposite, adjacent, or I can move my thing here and say this is 297. Either way, I got tan x 995. So I'll get 16.6 degrees when I do that. Okay, so the picture on that, the wording is a little rough, and I apologize about that. But in the end, that's what you're looking for. And finally, the last one. We got this building that we're trying to find the height of. That's our overall, what we're looking for. We got Maria. She's 5 feet tall. Up to her eyes, ground level, so she's going like this. 73 degrees angle of elevation. She's 50 feet away. And we want to know how high the building is. Well, we have a couple things to just pay attention to. We have to add at the end of this the 5 feet. Okay, so when I find x, which is going to be this part, I'll have to combine those two pieces. So when I do that, I will have tangent in this case, tangent 73. Opposite is x, adjacent is 50. So multiply 50 times tan 53, times tan 73, I mean. I'll get 163.5, and then make sure you add 5 to that. So then I'll get a grand total of 168.5 feet. That's how tall the building is. So we're using her height to be able to do that. All right? I think that's it. Yep. So the remainder of your work. So once you get done with this, double check your stuff. Hopefully that went well. Go back to starting, I think it's starting on page 23. Page 23 to 27 is Skills Core Extended with a little more challenging piece. Go back, work on that, see how you do with those, and I'll catch you on the next one. Have a good one. Let me know if you have any questions.